We'll continue with electrolysis today. We did a presentation on electrolysis yesterday, and I wanted to continue because I don't think we did enough examples yesterday. So let's do a few more examples so that more and more stuff about electrolysis is clear to us. Now in this slide I have taken NaCl, but molten NaCl. As I said yesterday, it is very important कि आप अपना electrolyte किस state में ले रहे हो. Yesterday's last example was aqueous NaCl. Today we are taking molten NaCl. Now molten NaCl will contain these two types of ions, sodium plus and chloride ions. And when you pass electricity, obviously the ions will start moving. Positive ions, sodium ion, will move towards cathode, and chloride ions will move towards anode. So that at cathode, reduction takes place. Sodium ion will gain the electron and get converted into sodium atom, neutral atom, which is a primary change. Yesterday we learned that conversion of an ion into a neutral species at its respective electrode is called as a primary change. Secondly, this is reduction because, as you can see, in this reaction there is gain of electrons. What happens at anode? Chloride ion loses this extra electron, forming a chloride radical. It forms a radical of chlorine. Again, this is a neutral species, so conversion of an ion into a neutral species is a primary change, and since the ion loses electrons, it is oxidation. Oxidation takes place at anode. Now in this case we can't collect this product. यहाँ पे primary change के बाद ही we collect the product. यहाँ पे it is not collected after primary change. After primary change, secondary change takes place, which is the radicals combine together and give us a molecule of chlorine gas, right? So that if we write an overall reaction, this is it. NaCl molten state gives us sodium in molten state and chlorine gas. Now if you remember yesterday's example, electrolysis of aqueous NaCl, वहाँ पे सोडियम नहीं डिस्चार्ज हुआ था, हाइड्रोजन. The products were hydrogen gas and chlorine gas. So you'll have to be careful. Aqueous कब करना है, molten कब करना है. Molten में products क्या होंगे, aqueous में products क्या होंगे. I've taken another example there today. Electrolysis of acidulated water. We're doing electrolysis of water. But water is a poor conductor of electricity and weakly ionized हो जाता है. So in order to increase its conductivity, we acidulate it. We add an acid to it. And in this case, the acid added is sulfuric acid, H2SO4. So जब आप water में H2SO4 डालोगे, these two reactions will take place and we'll have these three types of ions in our electrolytic mixture. Electrolytic cell में जब electrolysis हो जाएगी, सारे ये electrolyte as well as the acid, they will dissociate into their ions. We get these ions, H positive, OH negative and SO4 2 negative. H positive is common in both. Hydrogen water से भी H positive आता है, H2SO4 से भी H positive आता है, whereas another ion from water is OH negative and the negative ion from H2SO4 is SO4 2 negative. So when you pass the current, obviously positive ions will move towards the cathode and negative ions will move towards the anode. Now ion कौन सा discharge होगा? As I told you yesterday, अगर competition है दो ions के बीच में, अगर more than one ions है near the electrode, so कौन सा discharge होगा? It depends on their value of discharge potentials, and yesterday only we learned that lower the value, that ion will be discharged in preference to other ion. At cathode, we just have H positive from H2O and H positive from H2SO4. So it is the only ion present there, undergoes reduction, gains an electron, forms a radical. Conversion of ion into a neutral species is primary change, and the process taking place here is reduction. Now primary change wala product, we cannot, it is not the final product, we cannot isolate it. Secondary change takes place, radicals combine to form a molecule of hydrogen. Now at anode, now this is again important, we have two negatively charged ions. We have OH negative and SO4 2 negative. But at anode, OH negative is discharged. It obviously means that the discharge potential of OH negative is less than SO4 2 negative. That is why preferably OH negative will be released. It loses an electron, forms OH which is oxidation because it loses an electron, and its conversion of an ion into a neutral species is a primary change. Again, secondary change is needed here. 4OH, these neutral species, they combine to form 2 molecules of water, and we have a molecule of oxygen. I'm really sorry, इसमें ये 2 मेरा subscript करना था, मैंने superscript किया है. This is O2. Now overall reaction water की आप ले रहे हो liquid, it's a liquid, acidylated liquid though, and we get hydrogen gas and oxygen gas, right? Without acidulation, water को ionize करना, water के through electricity pass करना impossible है, because it's a poor conductor of electricity. Pure water is a poor conductor of electricity. इसकी electrolysis हम करते हैं only by this way, by adding an acid like sulfuric acid to it. Now this example, again a very very crucial example. Again let's go back to yesterday's presentation. आपको याद होगा कि मैंने कहा अगर इलेक्ट्रोड के नज़दीक 2 आयन्स है, 2 कैटायन्स है, फॉर एग्जांपल कैथोड के नज़दीक, तो कौन सा डिस्चार्ज होगा? 1, इट डिपेंड्स ऑन द वैल्यू ऑफ डिस्चार्ज पोटेंशियल. सेकेंड पॉइंट मैंने आपको बताया, इट ऑल्सो डिपेंड्स on what will be the products of the reaction. It is also determined by the nature of the electrode, nature of the material, किस material का electrode बना हुआ है. This example is very important. मैंने लिया है aqueous copper sulfate, है ये aqueous दोनों ही cases में, but in the first case we are using inert electrodes. This diagram is the diagram in which our electrode is aqueous copper sulfate and our electrodes are inert. Platinum के होते हैं inert electrodes. Whereas in the second one, we again have aqueous copper sulfate, but the electrodes are copper electrodes, which is not inert, right? Let us see what difference does the material of the electrode make in the nature of the products. I've taken this summarized picture from internet. Let's look at this first. Electrolysis of copper sulfate solution using platinum electrode. Now since it's an aqueous solution, हमारे पास ions क्या होंगे? Cu2 plus and SO4 2- from copper sulfate, H plus and OH negative from water. ये water molecule यहाँ पे नहीं है. These are the 4 types of ions present. Now at cathode, as you can see in the reaction, Cu2 plus is discharged, which means obviously Cu2 plus का discharge potential is lower than H plus. That is why preferably Cu2 plus is released as this atom, neutral atom. Primary change है ये, secondary change की ज़रूरत नहीं है. We can collect it as such. And anode पे भी 2 ions है, OH negative and SO4 2 negative. But as you can see in the reaction, OH negative has lower discharge potential. Therefore anode पे OH negative ही discharge होता है. OH negative loses 4, OH negative lose 4 electrons, giving us 4 OH, which is a primary change. And it is oxidation because they lose electrons. These OH, 4 OH combine together and they give us a molecule of water and oxygen. So that these are the products. Oxygen is evolved at anode. A reddish brown copper is deposited at cathode when you carry out the electrolysis of aqueous copper sulfate using platinum electrode, using neutral electrode. But what happens here? This is the example. We're doing the same thing. We're carrying out electrolysis of aqueous copper sulfate solution, but this time we are using copper electrode. Now pay attention to this. Again, it's an aqueous solution of copper sulfate. Ions present क्या होंगे? Cu2 plus, H plus, SO4 2 negative, OH negative. At cathode, the reaction is the same. Cu2 plus preferably discharge होता है, इसका discharge potential H plus से कम है. Therefore, there is a discharge of Cu2 plus. It undergoes reduction, gains electrons, and what we get at cathode is the same reddish brown copper. But what happens at anode? Let's look at this reaction. This is our reaction. This is our electrolytic cell in which we have used electrodes made of copper. What happens here? Around the anode, इसमें anode right hand side पर है. Anode के around एक तो हमारे पास OH negative ions है और हमारे पास SO4 2 negative है, right? Where am I? Here in this section. Anode पे हमारे पास negative ions होंगे, SO4 2 negative and OH negative. So competition should have been between these two कि कौन सा discharge होगा. But what happens actually here, यहाँ पे खुद material of the electrode की oxidation हो रही है. Material क्या है electrode का? Copper is the material. That copper itself, material of the electrode, is getting oxidized, continuously losing electrons and getting converted into Cu2+. Cu2+, which goes into the solution and later gets deposited on the cathode. This is what happens here. So as a result of which, at cathode reddish brown copper is deposited. No product is formed at anode. ना ही आपका SO4 नेगेटिव आयन वहाँ डिस्चार्ज होता है, ना ही OH नेगेटिव वहाँ डिस्चार्ज हो रहा है. वहाँ पे हो क्या रहा है? The anode itself, the material of the electrode is itself getting oxidized. Thus the only product formed is copper. एक तो कैथोड पे अपनी रिएक्शन से कॉपर बन ही रहा था, as you saw here, कैथोड पे कॉपर डिपॉजिट अपना हो ही रहा था. Secondly, यहाँ से भी जो कॉपर आ रहा है, it goes into the solution, later gets deposited on the electrode. So the only product is copper. When you do what? When you carry out the electrolysis of aqueous copper sulfate using copper electrodes, the only product is reddish brown copper. Whereas when you carry out the electrolysis of same aqueous copper sulfate using inert electrodes, for example platinum electrodes, what are the products? The products are copper and oxygen. Cathode पे copper हो जाएगा discharge and anode पे oxygen, right? So I'm sure by this example also आपको समझ आया होगा कि how critical it is to know, one, आप electrode molten ले रहे हो कि aqueous ले रहे हो, या अगर आप water ले रहे हो तो उसको acidulate किस acid से कर रहे हो, accordingly आपके ions होंगे present. Second, whether you are taking inert electrodes or you are taking electrodes made up of another material, right? Now the last slide is the importance of electrolysis. Why do we carry out electrolysis? What all do we get from electrolysis? Number one, production of hydrogen, one of the most important substances in chemistry. इसकी production electrolysis of water से ही होती है. Electrolysis is used for electrolytic extraction of very important metals like sodium, potassium, magnesium, calcium, right? Production of chlorine, again a very important substance. जब आप electrolysis करोगे aqueous NaCl की, one of the products is chlorine. Manufacture of heavy water, deuterium oxide. Deuterium is the isotope of hydrogen and simple water is H2O, heavy water is D2O. आप बना सकते हो D2O only by the method of electrolysis. Then electroplating and electrolytic refining जो metals की होती, will be studying I think both of them, electroplating in detail. Definitely I'm not sure about electrolytic refining. This is carried out by electrolysis.